Okay, so we are still in the same lesson. 3.7. We're still going to be dealing with solving a system using by graphing. But now what we're going to do is take real-world examples. We're going to have to create equations out of them, graph them, and figure out where they cross, and then interpret what the answer is. So this is exactly what we did on that Desmos activity. So we're going to do one example, and then we'll talk about the variety of problems that you may end up seeing, and we'll do some practice with how do I take English and write sentences. Okay. So we're going to be solving word problems by graphing. So today's date is 2/3/16. So here's our scenario. Or let's talk about it this way. So basically what you're going to be doing is read the word problem. I know that sounds silly, but that's what you need to do, and you need to read it a couple times. What you're going to find out is that there's two unknowns in this problem. You're used to the problems that we've solved, word problems in the past. There's been one unknown. So now you have two unknowns. So to solve an equation that has two variables that are unknown, we need to come up with two equations. Oops. Translate two equations. With the two unknowns. Now I'm going to write in parentheses. At this point, those are going to be our variables. Once we get through that, we're going to deal with graph the equations on the same axes, because we've basically created a system. Find the point of intersection and then the key part. In words, interpret the solution. So when you're writing the answer to a word problem, you have no ordered pair. You write it in words what it means. Okay, so that's going to be what we're going to be following, kind of our basic process. Okay, so let's go through our scenario. So as we go through this, and you have to write this out, okay? As we go through these scenarios, you need to ask yourself, who would I let be X and who would I let be Y? And I'm going to just say, let's just keep using those variables regardless of what our unknowns are, because we're going to define them and so that we can track them. So here's our situation. Gregory's Motorsports so it's the name of a company, has motorcycles in parentheses they explain that they have two wheels, which hopefully you all know, and ATVs, all-terrain vehicles. Oh, sorry, not apostrophe. And then in parentheses, four wheels, for those of you who don't know, in stock. The store has a total of 45 vehicles that together have 130 wheels. So what do you think they're going to ask us to solve for in this problem?
How many ATVs and how many?
Yeah. And it's interesting because what your book is saying, write and solve a system of equations that represents the situation, interpret the situation. But very quickly, Dylan, you saw that and said, well, how many of the motorcycles and how many ATVs are there? So that would be the situation. That's what we could solve from here. So the question we're going to answer is, how many motorcycles and how many ATVs are in stock? Okay. So we have two different things we're solving for. We're going to let one be x and we're going to let one be y. So let's choose x is blue, let's do y in purple. So let's come up with definitions of what does x represent. So for one of the things we're solving for, let's let it be x. What are we going to let be x? So the number of ATVs. We can't just say ATVs because we need to give a reason. What is it that we need to know about them? Okay, and what does y stand for? Number of motorcycles. Okay, so what's one equation that I could write about the number of ATVs and the number of motorcycles based on the information that they gave me? Simon?
So that together it equals 130 wheels.
Okay, how would I write wheels? So does x represent the number of wheels?
No.
No.
And represents the number of ATVs. So how could I figure out how many wheels for our ATVs? What did it tell us about the ATVs?
It has 4 wheels.
Okay, it has 4 wheels. So what we're going to do is we're going to write one equation that deals with the wheels. And we know that the ATVs have 4 wheels. So we're going to have 4 times the x. And how many wheels does the motorcycles have? 2 times the number of motorcycles would equal the number of wheels it mentioned in the problem. 130. Okay? And then we're going to write a second equation that's going to be based on what? What does the 45 represent? Number of vehicles. Okay, so how would I write an equation with our information that would tell us about the number of vehicles? So how many ATVs do we have? What does it say? What have we written? No. That's how many of the both of them I have. What have we written that says number of ATVs? X. What have we written that says the number of motorcycles? Y. What do we say that they add up to equal? What does it say in the problem? Not 130.
45.
Yeah, 45 talks about vehicles, 130 talked about the wheels. Okay, so my job is to now graph these. Now, these are both written in standard form, so I think what I'm going to do is I'm going to use intercepts to help me solve this one. So I'm going to take on the first one here, we're going to do 4x equals 130, divide by 4, and we get x equals, let's see, goes into 13 3 times with 1 left over, and 4 goes into 10 twice with 2 left over. and 2/4 is the same as a half. For the y-intercept, 2y equals 130, divide by 2, and we get y equals 2 goes into 13 6 times with 1 left over, and into 10 5 times. Okay. Over on this one, x equals 45, y equals 45. Okay. So here's what's interesting. I'm going to add in my graph paper now. There's no way I'm going to count by ones. Look at my numbers. There's no way I'm going to count by ones. So I'm going to have to count by a different scale. So I think what I'm going to count by is 5s. Okay? And let's see how far. And the other thing I notice is that my numbers are all positive. So I really need to focus only on the first quadrant of my axes, because that's the only place that numbers are going to show up. Okay? So let me think how, if I wanted to do this. So I would need to go 5, 10, 15, 3, 4, 5, 6, 50. So I should be okay here. It's going to be going up. That's going to be the more interesting one. Okay. Five, 10, 15, 20, 25, 30, 35, 40, 45. That's as far as I need to go on the x-axis. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Ooh, and we just made it 65. That's going to be my y-axis. So 5, 10, 15, 20, 25, 30, 35. And notice how messy that is. So I'm going to skip over. So 5, 10, 15, 20, 25, 30, 35, 40, 45. And then here I'm going to go on the outside. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, and we're at 65 at the top. So on the first one, I'm going to find 32, 50. So that would be between 30 and 35, so right there in the center. And the y was 65. Now, of course, you're going to draw a lot straighter than I just did. And here we're going to go to 45 and 45. Let's see. Okay. And we should be right here is where they cross. So what's the x number?
Wait, how'd you get 45 and 45?
I did x-intercept, okay, and y-intercept. So what's the coordinates of that ordered pair? What's this?
20 and 25.
20 and 25. Now, I can't write that as my answer. So I need to remember 20 represents the x, 25 represents the y.
How do you know which side is which? Like, oh, no.
So, because that's how all order pairs. So what does the x represent? What did we define x to mean? Number of ATVs. And we came up with the number, what's it say x is? 20.
20 ATVs and 25.
And that's exactly what our answer would be. So we would write our answer as, there are 20 ATVs and 25 motorcycles in stock. Okay. So we have just a couple minutes remaining before I give you your homework, because we're going to do a couple different things. So just what are some things that might show up similar to this? I see a lot of problems that deal with like number of dogs and cats at a shelter, and then they talk about their legs. Or no, not their legs. What was the other thing? Oh, they talk about, a comparison. How many more cats than dogs? And then you could have animals where one has 2 legs and one has 4 legs. And so you could have like that. So you might have a chicken and a cow problem. And then you could have problems that deal with 2 people in different ages. And so that you can create an equation out of that. So there's a lot of different scenarios that you guys are going to be seeing on your homework.